Good morning all, my name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is image processing. Today I am discussing about the topic, some basic relationships between pixels. Before going to this topic, what is the pixel, what is the pulse, and what are the relationship between the elements we will discuss. So, a digital image is composed of a finite number of elements, each of which has a particular location and value. So, these elements are referred to as picture elements, image elements, pulse, and pixels. So, pixel is the term most widely used to denote the elements of a digital image. Suppose the image has a some 4 into 4 pixels. Example I am taking. So, this I am taking as a x and y coordinates, x axis and y axis. So what are the, how many are there? Total 4 into 4 equal to 16 pixels are there. So that means 4 rows and 4 columns. So total 16 means 4 rows and 4 columns. So suppose I am taking a digital image is a finite number of elements, each of which has a particular location and value. So every image where we are copying in one location. Okay, everything we have one element. Every image has a particular element and finite elements of each which has a particular location and value. So these elements referred to as a picture elements, image elements, and pixels. So these pixels, how many are there? Total 16 pixels are there. So these 16 pixels we are referring to as a picture elements or image elements and pixels. So pixel is the term most widely used to denote the elements of a digital image. Most probably we are calling as these are the pixels. So this is one pixel. Okay, so that is a pixel. So after that we are going for the some basic relationships between the pixels. So what are the basic relationships between the pixels? Suppose a pixel I am taking as a p at the coordinates x, y has a 4 horizontal and vertical neighbors whose coordinates are given by x plus 1, y, x minus 1, y, x, y plus 1, x, y minus 1. So 4 coordinates is a x and y coordinates and 4 horizontal and vertical neighbors whose coordinates are given by. So it is a x-axis and it is a y-axis. So thus this image has a 4 sides are there. It is 1, it is 1, it is 1, and it is 1. So how many sides are there? 1, 2, 3, 4 sides are there. So these are called 4 neighbors. So 4 sides, 4 neighbors are there. So what are the x and y coordinates? Means x coordinate and y coordinate, horizontal and vertical. So these 4 coordinates, 4 neighbors, I am taking as a what are the coordinates for that one? That means x plus 1, y. One I am taking x plus 1, y. Another one x plus 1, y, x minus 1, y, x, y plus 1, x, y minus 1. Total 4 neighbors are there. 4 sides, 4 neighbors. So the set of pixels has called the 4 neighbors of P is denoted by n4 of P. So how many 4 neighbors are there? No? So n4 of P. So each pixel is a unit distance from x, y. X, y are the coordinates x and y. So and the sum of the neighbors of P lie outside the digital image if x, y is on the border of the image. So nd of P and n8 of P. Also what is this one? N8 of P means 8 neighbors. N4 means 4 neighbors. Like this, nd of means 8 d neighbors. So the 4 diagonal neighbors P has a x plus 1, y plus 1, x plus 1, y minus 1, x minus 1, y plus 1, x minus 1, y minus 1 and are denoted by nd of P. So total how many I am taking? 1, 2, 3, 4. So 4 I am taking 4 neighbor. So that is a n4 of P. So these points together with 4 neighbors and our 8 neighbors are denoted by. If I am taking 4 neighbor means n4 of P, 8 neighbors means n8 of P. So on, n neighbors or d neighbors, nd of P. D equal to, I'm taking 4, 8, so on. So if some points in ND of P and N8 of P fall outside the image if f of x comma y on the border of the image. So N8 means 8 neighbors are there. D means D neighbors. 4 means 4 neighbors are there. So if I'm taking 8 adjacency means I'm taking as a 3 by 3 matrix. Example I'm taking 1 0 0 0 1 0 0 0 1. Okay. So middle point is a my pixel. Okay. So surrounding how many are there? I'm taking as a 8. 1, 2, 3, 4, 5, 6, 7, 8. So total 8 adjacencies are there. So what are the 8 adjacencies means I'm taking as a x plus 1 comma y, x minus 1 comma y. So x plus 1 comma y plus 1, so on like this. So I'm taking as a 8 adjacency. So in this 8 adjacency, the outside of the image x comma y is on the border of the image. So I'm taking as a this like this 3 by 3 matrix means 9. So middle one I'm taking as a what is a particular image, this point of view how many are there. So total 8 adjacencies. So 4 adjacency means already we discussed. Suppose I'm taking one pixel, it is a 4 adjacency. Okay, 1, 2, 3, 4. So 2 pixels P and Q with values from V are 4 adjacency. Q is a set of N4 of P. Also I'm taking as a 8 adjacency means 2 pixels P and Q with values of V are 8 adjacencies if Q in the set of N8 of P. So it is N4 of P, that is a 4 adjacency. N8 of P means 8 adjacencies are there. So M adjacency means I'm taking NM. So 2 pixels P and Q, the values are V from M adjacent. Q is the N4 of P and Q is the ND of P and the set of whose values are from V. So 2 pixels P and Q are said to be connected in S matrix if there exists path between them consisting entirely of pixels in S. For any pixel P in S, the set of pixels that are connected to in S and is called connected to the components of S. So I am taking the following is a, it is like a matrix, it is a 3 by 3. So it is a 8 adjacency. So this one, what is my target means? It is a arrangement of pixels. Okay, we are arranged as a 3 by 3 matrix. Next, pixels that are in 8 adjacency because 8 are there. And third one is a M adjacency. So if I am taking a 8 adjacency with a 3 by 3 matrix, so 8 adjacency, why I am taking 1 means 1 to 1. What is the path between the 1? Shortest path or path selection. Suppose the path is from 1 to 1. Path from 1 to 1 means, suppose I am taking, what are the ones are there here? 1 to 1, 1 to 1, 1 to 1 and 1 to 1. So these are the paths are there. How many paths are there? Here 1, 2, 3, 4. 4 paths are there. Suppose I am asking you the short, which one is the shortest path? So 1, 2, 3, 4. So it is the shortest path. How many paths are there? 1, 2, 3. So if I am selecting the shortest path, here we are getting only 3 paths. But here only I am taking the path selection. So path selection means I am getting 4 paths. So path selection, how many are there? So how many possibilities are there? That is a path selection. So here shortest path means which one is the shortest path? Then we are reducing the paths. Pixel is the smallest element of an image, each pixel corresponding to any one value. In an 8-bit grayscale image, the value of the pixel between 0 and 255, the value of a pixel to any point corresponding to the intensities of the light, photons streaking at the point. Each pixel stores a value proportional to the light intensity at the particular location. So, Suppose I'm taking 256 into 256 pixels. Okay. So in the binary, 256 means I'm taking 0 to 255 pixels. 0 to 255. Total how many? 256 pixels are there. So total have the grayscale of 256. But what is the range of the pixels means in the grayscale? 0 to 255. So each pixel has the intensity values. Suppose I'm taking 0, 128, 85, 26, 83, 51, like this, so on. So each one has a intensity values are there. So each pixel we are applying some intensity values. So that is I'm calling as a pixel of the smallest element of an image. Each pixel corresponds to any value. Okay. So I'm taking any one of the value here. So in a 8-bit grayscale image, 8-bit means 3x3 matrix. I'm taking as a 3x3 matrix. That is a gray. So 3x3 grayscale means I'm giving the intensity values for the 3x3 matrix. So 8-bit grayscale image, the value of the pixel between 0 and 255. So 256 means 2 power 8. So it is a 8-bit. Okay. So 2 power 8 equal to 256. That is a 8-bit grayscale. 8-bit means 2 power 8 means 256 pixels. So 256 means I'm taking as a 0 to 255. So here 8-bit means 256. So the range is 0 to 255. The value of a pixel at any point corresponds to the intensity value of the light photon striking on that point. So each pixel store a value proportional to the light intensity at the particular location. So each pixel has the intensity values. So these are the gray values or gray levels. So each pixel with a gray level or intensity value is proportional to the particular location of the light intensity value. And what is the relation with the CCD array? We have seen that how the images are formed in the CCD array. So a pixel can be also be defined as how we are defining a pixel. So the smallest division of the CCD array is also known as a pixel. And each division of CCD array contains the value of against the intensity of the photon striking on it. This value can also be called as a pixel. So the CCD is one type of relationship between the pixels. That is, the image is formed in the CCD array. So a pixel can be defined as what are the how we are defining. There are the two defining states are there. First one is the smallest division. The CCD array is also known as pixel. Each division of CCD array contains the value against the intensity of the photon sticking to it. This value can be also be as a pixel. So I am taking, suppose it is I'm taking as a 3x3 pixel. Each has the intensity values. So each pixel has the intensity values. The against the intensity of the photon sticking on it, this value can also be called as a pixel. So each one, it is also called a pixel with intensity value. Okay, the gray value, the gray with pixel. So it is one example of the relationship between the pixels. Suppose it is one camera. So a sensor sense the intensity of the sticking photon. It is 1 pixel. So camera is capturing. When the camera is capturing, then creating an image. So sensor or sense the intensity of the striking photon. So when the sensor or camera is capturing one image, capturing one item or capturing one thing, so then it is creating image. It is creating one image. So thus that image has a number of pixels are there. So that image has a number of pixels. So depends on your sensor device, the pixels will be created. Depends on your device, which device you are choosing, depends on that one. The number of pixels should be changed. So that is the relationship between the pixels. So how we are calculating the number of pixels in an image? So we have defined an image as a two-dimensional signal or matrix. Then in that case, the number of cells would be equal to the number of rows multiplied with number of columns. This can be mathematically represented as, suppose here how many are there? So x and y axis. So we have defined an image as a two-dimensional signal. So x and y axis, it is a two-dimensional. Then in that case, the number of cell would be equal to the number of rows multiplied with the number of columns. So how many rows and columns? Suppose here number of rows into number of columns. Suppose I am taking here 3 rows into 3 columns. Okay, it is a 3 by 3. So 3 rows and 3 columns. So it is a 3 by 3 matrix. So how many number of rows and how many number of columns? We are multiplying with each. So 3 into 3, 9, 4 into 4, 16, like this. So it can be mathematically representing. How we are representing these pixels in the mathematical layer. Total number of pixels equal to number of rows into number of columns. Here I am taking 3 by 3 matrix, means 3 into 3 equal to how many? 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 pixels are created. So total number of pixels equal to number of rows into number of columns. Or we can say that number of x, y coordinates pairs make up with total number of pixels. Otherwise, I am taking as a x, y are the coordinators and these pairs make up with the total number of pixels. Okay, this is another way to calculate that one. And the more types of images we can see here. First one I am going for the gray level. The value of the pixel at any point denotes the intensity of image at that location, and that is also known as a gray level. So I am discussing about the gray level. So what is the relation to the pixel? So the value of the pixel at any point denotes the intensity of the image at that location, and that is also known as a gray level. Zero, 255, 128, 96, 28, again 0, 255, 128, 54. Suppose, so I am taking here 3 by 3 equal to 9 pixels are there. So each pixel has the intensity values are there. Each pixel with the intensity values are there. So here each pixel, so it is 1 pixel. It is 1 pixel. So what is the intensity value of this one? So each pixel, this pixel has an intensity value is 128 and it is a 0 and it is a 54. So how many pixels are there? Each pixel has the intensity values are there or not? Yes, we have 255. The pixel intensity value is a 255. So then I am calling as it is a gray level. So what is the pixel here means it is a gray level. Why I am calling it is a gray level means it has the intensity value is there. The pixel with the intensity value I am calling as a gray. So gray level. The pixel with intensity value, that is called a gray level. Suppose I have a pixel with I don't have any intensity value. So nothing is there. That is empty. So I didn't call it is a gray level. So then the value of the pixel in that image stores and bits per pixel, but it is value as a pixel of value. So I am taking as a, suppose 3 by 3 is equal to 9. So how many are there? Suppose I am taking 2 power 8, that is a 256. So 2 power 8 means 8 bits are there. Suppose I am taking 2 square means 4. So 4 pixels. So 2 means 2 bit. So number of bits per pixel is the depends on the pixel size, and it has the pixel can only be the value. Each value denotes the intensity of the light at that point of the image. Every image has the intensity values are there. Okay, these intensity values are I am calling as a gray levels. So a very unique value is 0. The value 0 means the absence of light. If anything, the intensity value is 0, that is the absence of light. Okay, there is nothing is there in that pixel. And it means that 0 denotes dark. And it further means that when ever a pixel has a value of 0, it means that point black color would be formed. Suppose here 0 means it is completely blackish. Okay, here 255 means it is black value is increased, then it is going to be white. Okay, if I am taking 0 means starting value is 0 means highest value means 255 is a white value. So 0 to 255, so black. 0 means completely black. So here I am mentioning as a 0 denotes the dark, that is a black value, and the pixel has a value of 0. It means that point black color would be the formed. So when I'm applying the 0 in the intensity value, then black color will be formed. When I'm applying the 255 means white color will be applied. And the image matrix have a filled up with 0 and all the pixels have a value of 0. If we were to calculate the total number of pixels from the matrix, how we are going to be? So how we are calculating the number of pixels? So the pixels have the intensity values, we are discussing the gray level, but how many pixels are there in that matrix? How we are calculating? So what is the formula? Number of pixels equal to total number of rows into total number of columns. So I am calling as it is a 3 by 3 matrix. Okay, 3 by 3 means 9. How many? 3 by 3 means 3 rows and 3 columns. So total 9 are there. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3 into 3, 3 rows into 3 columns equal to 9 pixels are there. It means that an image would be formed as 9 pixels and that image would have a dimensions of 3 rows into 3 columns. Most important, that image would be a black. So the resulting image that would be made would be something like this. Okay. So I'm taking as 9 means 3 by 3. Okay. So the pixel size is a 9, that is a 3 by 3. And what are the 5 frames? The transformation between these frames. So I'm taking about the pixel, or I'm taking about the image. So before the image, what are the 5 frames are there in the image? Means first one is a object coordinates, that is a 3D. Another one is a world coordinates and a camera coordinates, image plane coordinates, pixel coordinate, 2D. So I'm taking one object. Okay, suppose that one person, I'm taking it is an object. Okay, this object I'm considering as a 3D and a world coordinate. Okay, I'm taking is forming one frame, world coordinate, and a camera coordinate. So I'm taking one sensor to capture this image. Okay, I'm one sensor to capture this image and image plane coordinate. So what is the image size? So how much? What is the size of the image? So after capturing this one, I'm getting, suppose 256 pixels. I'm getting, example I'm taking. Okay, 256 pixels. I'm getting this image when I'm capturing the image. So pixel coordinates. So what is the coordinate? 256 means 2 power 8. So that is a 8 bit. So 8 bit. I'm getting the 8 bit. Okay. Suppose I'm getting otherwise 3 by 3 equal to 9 pixels. Okay. 9 pixels means it is a 3 rows and 3 columns. Okay. So how we are getting 2 power 8 equal to 256? How we know? So depends on your camera or sensor. It will be creating the pixels. Okay. If the sensor or camera will be changed, then maybe the pixel coordinates also will be changed. So what are the 5 frames means? Before creating the image, what are the 5 stages are there? That is the object coordinate. So which object you are selecting? Okay, that one. And the world coordinate. What are the surroundings of that object? And the camera coordinate. Which type of camera or which type of sensor you are using? And image plane coordinate. So image plane means which type of image you are selecting. So after selection of that one image, suppose the image is formed when I am capturing the image. So that image has the how many pixels are there. Suppose I am taking one digital cam with some intensity is there. So I am getting 256 pixels. That is a 2 power 8. So I am getting the 8 bit binary. Suppose I am taking 8 pixels, 9 pixels. That is a 3 by 3 matrix. I am taking 3 rows and 3 columns. That is a pixel coordinate. So here one image is there, that how a 3D scene in transferring into the 2D within an image of pixels. Now we will explain the concept of mathematically. So here a 3D is there, but I am taking 2D. Why I am taking 3D and 2D? You can see here, object coordinate is a 3D. So I am choosing the object in the form of 3D, and the world coordinate also in the form of 3D, and the camera coordinate also in 3D, and the image plane is in 2D, and the pixel coordinate in 2D. So this 3D is converted to the 2D. How it is possible? So 3D means 3-dimensional, that is the x, y, z coordinates. 2D means only x and y coordinates. So 3D equal to x, y, z coordinates, and 2D is a x and y coordinate. So if I am taking one sensor with capturing the image, okay, it is going as like this direction. Okay, so when I'm going this like this direction, it is already in y-axis. Okay, so what is the normal? This one and this one. Okay, it is a x-axis and it is a y-axis. Okay, this 3D is converted to the like this. Okay, x and y-axis. Okay, so where suppose I'm taking one y equal to 3D object and another y equal to 2D image. Okay, this object is a 3D object and it is a 2D image. So 3D object with a 2D image and f equal to focal length of the camera. So what is the focal length of the camera? Here 3D is there. Already camera is in the 3D. Okay. And z equal to distance between object and the camera. Suppose I am taking it is the object and it is a camera. Okay, or it is a object with camera. Okay, it is a 3D and it is a 2D. So now there are two different angles formed in that transformation which are represented by Q. Only when I am capturing the image, that is a 2-dimensional. Why? Because camera is a 3D but object is a 2-dimensional. So output also I am getting as a 2-dimensional. So the first angle is tan theta equal to y by f. Only I am getting two angles, and where the minus denotes that image is inverted. Why? Because the image, you can see here, it is the x-axis. Actually it is a y-axis, but it is a down. We are getting the down. That means minus y. So minus y by f. So tan theta equal to y by z. So comparing these two equations, y equal to minus f, because reverse angle, minus f into y by z. From this equation we can see that when the rays of light reflect back after striking from the object passed from the camera, an invert image is formed. We can better understand this with an example. Okay, so I'm taking, so when I'm comparing with this one, we are calculating, I'm taking this one as a better example. This image, I'm taking one example. So for example, I am calculating one image. Suppose an image has been taken a person 5 meters tall and standing at a distance of 50 meters from the camera, and we have to tell that what is the size of the image of the person with a camera focal length is 50 mm. Okay. A person with 5 meters tall. Okay, and here I am taking one camera. Okay, so standing in a distance of 50 meters from the camera. So here camera is there. What is the different distance between the person and the camera is a 50 meters. Okay, and we have to tell that what is the size of the image of the person with a camera of focal length is 50 mm. So the camera focal length is a 50 mm. So the camera focal length is a 50 mm. So what is the size of the in-person image we are creating after capturing this one? The camera is capturing that person. What is the person with the camera focal length is 50 mm. So what is the size of the image after capturing the image? So solution, how we are calculate. So focal length is in millimeters. So we have to convert it into the millimeter in order to calculate it. Y equal to 5000 mm. So 5 meters means 50 mm means we are calculating to the 5000 mm and equal to f equal to 50 mm. Already they give 50 mm. So here 5 meters is there. I am converting to the mm, 5000 mm, and z equal to 50,000 mm. It is a 50,000, 5,000 and 50 mm. The distance between this one is a distance, and it is a person height, and it is a camera. Okay. So the putting the values in the formula we can get. Already we know that what is the formula? Y equal to minus f into y by z. So is equal to minus into 50. Already if we know that 5000. What is the 5000 means? The person height is a 5000 divided by what is the distance between the camera and the person is equal to 50,000 mm. Equal to what is answer means I am getting minus 5 mm. So the minus sign indicates that the image is inverted. So the image inverted means the image is like this. Okay, invert image. Okay, so my again minus sign means that the image is in the form of inverted. So BPP or bits per pixel denotes that the number of bits per pixel. The number of different colors in an image is depends on the depth of the color or bits per pixel. Till now we discussed 3 by 3 matrix equal to 9. What are the gray levels are there? So we are discussing about the gray levels with black and white. So suppose the intensity value is 0 means black. The intensity value is 255 means white. But here now discussing that we are going to the pixel with a color coding. Okay, the pixel with color intensity values. So how we are calculating the color? So we are going, before going to the color bits per pixel, we have to know bits per pixel. It is denote the number of bits per pixel, and the number of different colors of an image is denoted on the depth of the color or bits per pixel. So the bits is mathematics. It's just like playing the binary bits, or how many numbers can be represented by 1 bit. Suppose I'm taking 1 bit. So what is a 1 bit means? 0 or 1 in the form of binary. 1 bit means in the form of binary. Okay. So I'm taking 2 bit combinations. 2 bit means it is a form of binary. So we have to mention in the binary form 00, 01, 10, 11. How many probabilities are there? So total 4. How we know 2 bits means 2 square equal to 4 probabilities. Here 1 bit means 2 power 1 equal 2 probabilities. What are the 2 probabilities? 0 and 1. 2 square means 4 probabilities. 00, 01, 10, 11. So how many 2 bits combinations can be made? So total 4 combinations. How can you know means it is a 2 bit, 2 square equal to 4 combinations. 1, 2, 3, 4. So here 2 bit, 2 power 1, sorry 1 bit. 1 bit means 2 power 1 means 2 combinations, 0 and 1 combination. So in this, the basic relation between the pixels means I'm taking one pixel. So the pixel is a square shape. So how many sides are there? So total 4 sides are there. So I'm taking the 4 neighbor of that one. So a digital image is composed of a finite number of elements, each of which has a particular location and value. So every image we have to save in a particular location. Okay. So these elements, so how many pixels are there? In the pixels were in form of elements. The picture with image elements are pels and pixels. Pixel in the term of while used to denote the elements of a image. So the number of pixels are there, though that in terms, in the general terms, we are using or we are denoting as a elements of a digital image. So how many are there? Suppose I'm taking as a 4 neighbor or 8 neighbor. Suppose I'm taking x, y are the coordinates, x and y are the coordinates for the image. So how many neighbors are there? 4 neighbors. X plus 1 comma y, x minus 1 comma y, x comma y plus 1, x comma y minus 1. So these are the 4 neighbor. If I'm going for the 8 neighbor, how we are denoting? So n8 of p. n8 of p means x plus 1 comma y plus 1, x plus 1 comma y minus 1, x minus 1 comma y plus 1, x minus 1 comma minus 1, or the so on. It is a nd of p. Okay. So these are the 4 neighbor n4 of p, 8 neighbor n8 of p. 4 adjacency and 8 adjacency. So 4 means n4 of p, d means nd, m adjacency means nm. So here I am taking one example of 3 by 3 matrix or 8 adjacency. So from this point of view, how many are there means 8. So it is a 8 adjacency. So the arrangement of pixels are with 8 adjacency, and dash numbers are the shortest path or path selection. Okay, these are the path selections. Okay, path selection is different, shortest path is different. So it is the pixel is the smallest element of an image, each pixel corresponding to any value. In an 8-bit grayscale image, the value of the pixel between 0 to 255, the value of pixel at any point corresponds to the intensity of the light photons streaking at the point. Each pixel stores a value proportional to the light intensity at that particular location. So how many are there? So total here I am taking 256 pixels are there. So 256 means in terms of 2 power 8. So 8 bit. It is the size is that 8 bit. So the 8 bit grayscale means 256 we are getting. So each have the what are the ranges 0 to 255. So these are called intensity values 128, 85, some 96, some 80, 76. Okay, it is 0. So these are the intensity values. It is also called gray values or gray levels. So a pixel with gray levels I am calling as a intensity values. Okay. So so 8-bit grayscale image, the value of the pixel between 0 to 255, the value of a pixel at any point corresponding to the intensity of the light photon sticking at that point. Each pixel stores a value proportional to the light intensity, so the particular location. So every image need a location. To store the image. So every image have a particular location to save the image. So each pixel stores a value proportional to the light intensity at that particular location. And what is the relationship between the pixels? So the small we have to see that the image is formed of the CCD array. So a pixel can be classified as a defined as a two ways. That is the smallest division of the CCD array is known as a pixel. Okay, smallest division, that is also called CCD or pixel, and each division of CCD array contains the value against the intensity of the photon sticking on that. The value can also be called as a pixel. So there are two definitions, two variations out there to defining a pixel value. And here one example of creating an image. So here I am creating one image. So if I'm creating the image, it means what I need, the major role is a sensor, and what we are capturing, I want to capture one person or one item or one anything. Okay, I'm taking one person. Okay, so the person with a camera, that is a sensor. It senses the intensity of striking photon. Okay, one pixel with a sensor. So after capturing the image from the camera, suppose one person is there. Camera capturing Okay. So camera is a sensor or source. Here sensor is a, I'm taking as a one camera is a source. He is capturing a person. Okay. So when immediately the person is captured means the image will be created. So how many pixels are there? That depends on your device, depends on your physical device, the pixels will be changed. So the pixels are created, the pixels are formed. So how can you calculate how many number of pixels are there? Suppose manually 9, 15, 20 I will be calculate, but 1024 or 10,000, 5,000, how can we manually, how can you calculate? So we have one formula to calculate. So we are calculating the image with the pixels, that is I am taking as a 2-dimensional matrix. In that I am taking as a one pel. So rows and columns, multiplying the rows and columns, that is a number of pixels. So the total number of pixels with the number of rows and number of columns. Or we can say that number of x, y coordinates. Okay, it is x, it is a y coordinate. And we will look up in more detail the tutorial. The image has calculating the pixels in a color image. Okay. First I am taking as a gray level. Already we know that. So the image with the values, that is a gray value. The image with the gray value. What is the gray value here? 128. So it is called gray level. The image with the intensity values. It is also called gray level. So the image, it is in 1 pixel. In that pixel, 54 is a intensity value. So the pixel with the intensity value, that is called gray level. So that is called the gray level. The value of a pixel at any point denotes the intensity of an image, that is a gray level, and that is known as a gray level. So okay, gray level means pixel with intensity value. The pixel with intensity value, that is I am calling as a gray level. And the pixel in that image stores and bits per pixel, and the concept of the pixel value equal to I am taking 0. Why I am taking 0 means it is I am taking 0. Suppose the pixel suppose here the pixel values are 0. That means 0 means I am taking as a there is nothing, there is no value. So I am considering as a it is a black. So the pixel is a 255. That is a highest value. I am taking as it is a white. So the intensity values are 0 to 255. So the lowest value I am calling as a black. If the lowest value is calling as a black means highest value I am taking as a white. So the image matrix has the filled with 0, all the pixel values of 0. We can calculate the total number of pixels from the matrix. Okay. So total number of pixels. Suppose here I am taking how many total number of pixels? 3 by 3. So 3 rows into 3 columns equal to 9 pixels. It means that the image would form as a 9 pixels, that is a 3 rows and 3 columns. And what are the 5 frames of the image? Means image object coordinates, which object you are taking. Suppose I am taking one person, it is one object. And world coordinate, the surrounding of the frame you are creating, that is a world. And a camera coordinate, which type of camera or which type of sensor you are using. And image plane coordinate. So how can you capturing the image from the camera? And a pixel coordinate. After creating the image is created. So what is the size of that image? So that is a pixel coordinate. If I have to know the image size, then we have to know pixel coordinate. Then only we can identify the image size. Okay, there are the 5 frames are there to creating an image. So if I am taking, it is a 3D to 2D conversion. 3D to 2D conversion. Okay, y equal to 3D and 2D, and what is the focal length, what is the formula, tan theta equal to minus y by f. So we are calculating the person. It is the person with the height equal to 5 meters and the camera is a 50 mm. What is the distance between the person and the camera equal to 50 meters? So what is the image size? So we are calculating using this formula. The image size is a minus 5 mm. So, okay, the inversion of the image. Okay. So it is a basic relation between the pixels. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.